So first of all, thanks everybody for coming, joining us today. My name is TJ VanToll. I work for a company called Telerik. If you haven't heard of us before, we conveniently have a booth right outside here that you come talk to us afterwards. But I'm here today to talk to you about NativeScript. And my first question is, how many people here had heard of NativeScript before you probably Googled it earlier today to figure out whether you wanted to come to this talk? Okay, a couple of people, halfway decent. NativeScript is actually fairly new. Specifically, we actually launched the public beta of this thing a week ago today. So very, very new. NativeScript's actually been in development for about 1 to 2 years internally. It's a project that's been going on for quite a long time. We at Telerik have a long history of building UI controls for different platforms. We have UI controls for iOS, Android. We've actually had Windows Phone controls for like 3 or 4 years. So the problem of being able to build these cross-platform apps is something that we've dealt with firsthand for a lot of years and really struggled with, and that's really where NativeScript came out of. NativeScript was private for about a year. We had an insiders program providing feedback to us, and as of last week, we went live with it. We had our public beta, what we're calling version 0.9, that's out, and if you go to nativescript.org today, that's what you can go peruse, you could download, you could give it a shot, you could let us know what you think. NativeScript is completely open source, meaning if you go to github.com/NativeScript, if you want to multitask as part of this talk, you can peruse the various repos that make up NativeScript. I'll be talking about some of those repos and what they are and how you can even contribute to them if you'd like throughout this talk. Our 1.0, or basically our stable release, is planned for May this year. We're planning on adding Windows Phone support. Right now, the version that you download online contains just iOS and Android support, but we have Windows support in the works. It's coming soon. So expect that around May. Now you might be wondering, well, okay, that's great, but what actually is NativeScript? I like to think of NativeScript as a runtime that lets you build completely native apps that run on these various platforms. To give you a metaphor, I like to think of NativeScript as a bridge. It basically is what connects JavaScript code to these native platform APIs, Android, iOS, and Windows Phone. Now, there are a whole lot of technologies that claim to do something like this or that do something like this with various levels of success. So I think the best way to explain what NativeScript is, or really what differentiates NativeScript, or what makes NativeScript cool, is to talk about NativeScript in comparison to some things that you may already know. So out of curiosity, how many people here are at least familiar with Cordova or PhoneGap? Okay, I think that's most people. So if you're not, PhoneGap is a way that you can wrap up a HTML, a web-based product in a wrapper, essentially a WebView wrapper, and deploy it as a native app. Now what makes NativeScript different than PhoneGap or different than Cordova is that in NativeScript there is no DOM, there is no HTML. NativeScript uses JavaScript for its logic, and it also uses a CSS implementation for styling, but we use completely native UI components. So you type something like button, and we delegate that down to a UI button on iOS and Android native button as well. How many people, the second logo there is actually Xamarin. Anybody here familiar with Xamarin? A couple hands, okay. Xamarin is actually, in a way, somewhat similar to NativeScript, with the big difference being Xamarin, you write your code in C#. Xamarin is very specifically targeted at the C# developer that wants to build native apps. But Xamarin does something a little different in that they cross-compile. And what that means is basically they take that C# code and they have a really quite clever process that turns that into Objective-C or Android code that runs then directly on native apps. And if you're familiar with Titanium, Titanium actually does something quite similar now. In Titanium, you write JavaScript code. They have, again, a quite clever cross-compile solution that turns that into native code for you.
So what's the difference between NativeScript and Titanium?
And Titanium? So what makes NativeScript different is the way that we allow you to access native APIs. So we don't cross-compile. There is no cross-compilation involved. The JavaScript you write actually runs directly on your device. And so I have an example of this here. And I'm going to leave this up here for a minute or two because this code can kind of mess with your brain a little bit because it's kind of this odd mismatch between JavaScript and Java code. This is actually the very last piece of code I would want to show to a beginner who's trying to learn the difference between Java and JavaScript, because in a way this is kind of both. So this is code that actually runs on the NativeScript Android runtime. And taking this from top to bottom, that top line of code will actually truly instantiate a Java time object. So it'll call that time objects, or that time class's constructor. It'll save off a proxy reference to that object, return that reference to JavaScript, so that subsequent calls, that set call and that format call, get delegated to that Java object, which will run natively and return a result to JavaScript, which in this case, it's logging the January 1st here. The best metaphor I like to use for this is the Matrix. Now, how many Matrix fans? Yes. I'm a big fan of the Matrix. And I actually think it makes a lot of sense for this, because this can blow your mind at first. Like, this is kind of weird, like how NativeScript actually does this. And remember that NativeScript is cross-platform as well, so the same sort of code can be written for iOS. So the same type thing here. This is JavaScript code. So these are all valid JavaScript context, even though the APIs are weird. This is actually calling an Objective-C UI alert view, setting its message property, and then calling a few methods that are Objective-C methods. And if you were to look at the iOS documentation, you could actually go ahead and make a mapping. You could say, oh, well, that's the message property on these docs, and these are the methods that are available, because NativeScript is actually making the complete native platform available to JavaScript. So there's no cross-compile. That code is actually running. Which begs the obvious question, well, wait, what? How in the world does any of that work? And I want to warn you before I get into this, I think it's actually important to take a bit of a deep dive and really to dive into how this works. And I say that for a few reasons, because it can be a little complicated. I mostly say that because, you had a question?
Yes, so you're saying, let's say I'm building this app using NativeScript, right? I would actually still go to the documentation page for each one of these, iOS or Java or J3.
Yep, so the question is, would you still, like you're building a NativeScript app, would you be going out to the Android and iOS documentation? And as you'll see, NativeScript provides a lot of cross-platform ways of doing things that kind of build on top of this, so that you're not only writing like Objective-C-ified JavaScript and Java-ified JavaScript. In fact, writing that code is kind of rare. But I do want to dive into how this works, because I think it's really important to understanding the architecture to how these apps come together. Because as you'll see, like this whole entire NativeScript ecosystem really builds upon each other. And I also think this is kind of cool to discuss how this works. I always get excited to talk about this. The first thing to know about any of this code is that it all runs on JavaScript VMs, or virtual machines. And if you don't know what that is, it's basically just software what actually runs JavaScript. So browsers, your Internet Explorers, your Chromes, your Firefox, they all have JavaScript virtual machines. JavaScript Core is what NativeScript uses on iOS, and V8 is what NativeScript uses on Android. And our early implementations of Windows are using JavaScript Core as well. So basically what NativeScript does is, as part of your app package, it's packaging up a JavaScript virtual machine. And the virtual machine itself is a bunch of C++ code. That's how all of these virtual machines happen to be implemented. So NativeScript packages one of these things up. So knowing that, if we go back to these code blocks, you can now know that that top code there, it actually does run on V8. NativeScript sends that code through V8 to run, and the code on the bottom runs on JavaScript Core. Now, Google Chrome also uses V8, both on its desktop browser and Android. So can anybody tell me, if I took that top block of code there and ran it in Chrome, what would Chrome say? What would desktop Chrome say? Come on. Anybody? What error would you get if you tried to run that code? If you type that into the Chrome DevTools right now, what would it complain about? About Android. Chrome doesn't know what Android is. Like, there's no Android global object. Chrome knows about things like window and document, but it has no idea what Android is. So the next piece to the puzzle to how NativeScript works is, how does NativeScript know what these native APIs are? And these are actually in NativeScript completely separate processes. So are people in here, like, how many people know the term reflection? A couple, okay, quite a few people. That's probably half the room. NativeScript uses this technique known as reflection, or you might call it introspection, depending on you get to argue about the correct computer science-y definition of the thing. But basically, if you don't know what they are, there are these APIs that a lot of libraries, like Java in particular, provide that lets you learn about the platform itself. It says, like, okay, I have an object. Like, what can I do with it? What methods are available? What properties are available? And so basically what NativeScript does is it has these separate repos, these separate processes that just build a JavaScript representation of the entire platform. So on Android, that would mean, like, okay, well, there's like two global things, Java and Android, and then just walk down the tree to see completely what's available and to build what we refer to as metadata, basically build a metadata representation of these platforms. Now, as you might imagine, from a performance perspective, these things don't run especially quickly. It takes a little bit of time to, like, recursively build a map of the entire platform. And so because of that, those processes are done separately. It's not like when your app kicks up, like NativeScript starts like, let's map out the entire platform. It's done as part of a separate task, and the build injects it so that NativeScript can inspect this metadata. The next piece of the puzzle is actually dealing with these JavaScript VMs. And this is something I didn't know before I started working on NativeScript, but I think it's something that a lot of people, that you can understand. And so these JavaScript VMs, as I said before, they're basically these C++ libraries, but they have these APIs. Like, there's things you can do to manipulate the JavaScript environment. And if you think about it, it kind of makes sense. Like, how does Chrome tell V8 like what the window object is? Because the window object, that's not a JavaScript thing. Like, if you look in the ECMAScript spec, it's not going to tell you this is what a window object is. It's a browser thing. So the browser has to have some way of telling V8, here's what window is and here's what it does. So as it turns out, V8 has all these APIs for injecting that sort of thing, for showing off that sort of behavior. And if you've done any Node.js work before, or at least familiar with what it works, Node.js also leverages V8. And Node does the same sort of thing. It injects something, it injects the require method, for instance. It injects like this exports keyword that's all kind of magic. So these VMs have all sorts of ways that you can configure the JavaScript environment to meet your needs. And so basically, what NativeScript does is it takes that metadata. Remember, NativeScript has this representation of these native platforms, and it injects it in. So it tells the JavaScript VM, like, oh, here's how you can know what Android is. We'll just make an Android object available. So the last piece of the puzzle, now I promise I'll move on from the tech deep dive here, because the last piece of the puzzle, if we go back to this line of code here, this runs on V8. NativeScript's metadata process is how it knows about all these APIs. But the last piece of the puzzle is how does NativeScript actually make the true bridge? That is, when that time call happens in JavaScript, because that'll happen in V8, how does NativeScript then know that it needs to instantiate a Java time object? The answer is actually, again, in those C++ APIs. One of the things those JavaScript VMs let you do is register callbacks. And you can think of callbacks almost like, if you're familiar with them, that concept in JavaScript is actually kind of the same sort of thing, in that these JavaScript VMs say, every time something happens in JavaScript, like there's some C++ code that you have the potential to run if you want to. So NativeScript just listens to all these things so it can take action. So in this specific case, with this line of code, V8, since this is Android code here, V8 has a constructor callback. That is, whenever a constructor happens in JavaScript, run this C++ code. So what NativeScript does is it says, OK, I'm just going to refer to my metadata, and oh, looks like I need to actually go and instantiate a native time object. On Android, it uses this thing called JNI. It's the bottom bullet there. C++ code, the NativeScript runtime is a bunch of C++. C++ on Android, just because of the way Android works, can't just call Java. It's just not the way the Android architecture works. But this thing called JNI makes that possible. JNI is actually like the physical bridge in the metaphor of NativeScript. On iOS, the situation is actually easier because C++ code actually can call Objective-C APIs. So it's actually one less step on iOS. So to wrap all of this up, all of this craziness up, the reason you can do this on NativeScript is because when this code runs, NativeScript knows about the platform because of the metadata it's generated. When the appropriate callbacks, the C++ callbacks happen, NativeScript has the chance to do something. It'll consult its metadata. In this case, it'll find out that it needs to go and instantiate a time object. And it'll return a JavaScript object that basically acts as a proxy. So NativeScript has a way of mapping subsequent calls and mapping those to the native object. So to keep the metaphor of the matrix running, hopefully you feel a little bit more like Neo after he has learned Kung Fu. But to the point of the question earlier, I don't want to give you the sense that even explaining how this works, and I admit like it can be a little complex and overwhelming, that you don't necessarily have to really understand how that works, because in NativeScript you're not really writing native code. You're not writing that sort of code all the time. The cool thing about NativeScript is that you can write that sort of thing when you need to, but the thing in NativeScript that keeps you from having to do that a lot is this concept of Tns modules. And TNS is just short for Telerik NativeScript. We use it as a shorthand because we're lazy typers lots of times. But they're basically NativeScript provided modules that give you cross-platform functionality. So basically, they abstract away that messy platform-specific code so that you don't have to know, like, how do I make an HTTP call on iOS? Because it's actually way harder than it should be. And just to give you an example, I think showing actual code is a lot easier here. So let's say you need to allocate a file as part of your mobile app. It's a pretty common thing to need to do. What you could do, based off the NativeScript runtime stuff that we talked about earlier, is you could write the code that shows up on the bottom half of the screen. For Android, you could say, well, with the NativeScript runtime, I instantiate a file with new java.io.file, and NativeScript will go ahead and instantiate a file for you. And you could write that Objective-C abomination that shows up on the bottom of the screen for your iOS app. But you'd actually be far better off using the Telerik, or the NativeScript provided file system module, which that top line of code actually requires, and the second line of code uses. And there are a few cool things about this to me. The first is that if you notice that require method there, I guess how many people here have done some node work, even if it's just using like grunt or gulp? Okay, a couple people in the room. So if you've done node work before, that require method is going to look fairly familiar. And NativeScript actually follows the common JS spec, which is the same spec that Node uses to define modules. Meaning if you're familiar with Node's convention, you're really already going to know how to write files and to write modules as part of your NativeScript apps. And if you don't, even if you don't, it's fairly easy to understand. All this is doing is saying, I need to require this other JavaScript module to use in my application. And it also means the conventions you use are also applicable outside of NativeScript. You're basically learning the same thing that you would need to write a Node app. The other thing cool to me is that even though these modules are kind of abstracting you from the native platform, they're written, like if you were to dig into the file system module, the actual source code for it, you're going to find a bunch of code that looks like the bottom of the screen, which I think is cool because it makes things really debuggable. Like if you want to know, well, what native APIs is NativeScript actually using here, like it's really easy to dive in and look at what NativeScript's doing to build on top of it. It's really inspectable, really debuggable because of this architecture. And just to give you another example, there's like 50 or 60 NativeScript modules now, and we're working on creating more. But like we handle the most common situations. So let's say you need an HTTP module, another common thing to need to do in your app. As I said, you could, if you really wanted to, dive in and write Android and iOS specific code to handle that HTTP call. Or you could use the HTTP module to do that for you. So you could use http.getJSON and chain that with a then call to do the logic in your app. Now, because of this approach, and because of the NativeScript runtime, these modules are actually fairly simple to write yourself. By chance, has anybody in here written a Cordova or PhoneGap plugin before? Okay, a couple people. Cool. So at Telerik, we're actually big fans of Cordova. We have a Cordova plugin marketplace. We really love the Cordova ecosystem. But one thing we don't like so much is that we find Cordova and PhoneGap plugins kind of verbose to write. Like there's a bunch of ceremony involved with it. Like you have to create this XML file, and then you have to dive into native code, and it's quite a bit of work. And we find that the NativeScript modules are considerably easier to write and to maintain and to use. This is actually a completely functional NativeScript module here. In this case, I wanted to get the OS version. So in my app, for whatever reason, I needed to know, like, am I on iOS 8 or am I on Android 5 or 4 or whatever the case may be. And you can see that the NativeScript runtime actually makes accessing these properties quite simple. I don't have to dig in and create some like .objective-C files and .java files in order to implement this. Again, if you're familiar with Node.js, you might notice that module.exports keyword. It's actually the same thing you would use in a Node app. Basically what it's saying, for those of you that aren't familiar, is this is the API that I want my module to actually export, or basically what I want to make available for files that use this file. So if you look at how to use this thing, you would just require the module, and because it was exporting an object with a version property, that's what you can just immediately use after the require call. The other thing cool to note, you may have noticed the comments up here, the .ios.js and .android.js. This is basically, this is actually what I think is a really cool mechanism that NativeScript provides for you to fork your code. And basically this does, as it kind of implies, NativeScript will automatically choose the correct file based off the platform it's running on. Meaning, when this code here runs in an iOS app, NativeScript's automatically going to pick the .ios.js implementation for you. And when this is running on Android, it's going to pick the .android.js implementation for you as well. And all of NativeScript's provided modules, and I'll dig into some of them in a few minutes, follow this same convention. So you can dig into the NativeScript implementations. You'll see a bunch of .ios, .js, .android.js files as part of your app. And it actually provides a fairly easy way to fork your code when you need to do that sort of thing. I added this just the other day because kind of last minute, but one cool thing is I mentioned that we released NativeScript a week ago, and we actually had some guy about 6 or 7 hours after the release create one of these modules. And it's a very simple module. All it does is do some number formatting, and it only supports Android at the moment. But we thought it was pretty cool that somebody, it's almost like a testament to our ecosystem that somebody was able to create this thing so quick. We were actually dumbfounded that somebody did this. But the next question, I guess, this leads to is, well, how in the world do you turn this into an app? So you have some modules, you can make some HTTP calls on Android, but that's not going to build a UI for you. You're not going to have an application for that for you. And actually, there's 2 ways that you can use NativeScript. So you can use NativeScript as part of the Telerik Platform, or you can use the NativeScript CLI. I actually won't be talking about the Telerik Platform today other than this quick reference. The Telerik Platform is a paid product that Telerik makes. So it's intended to provide the extra tools and services you need to make an app. So it'll do things like help you send push notifications, give you a place you could store your data, your files, analytics, cloud builds, a bunch of those types of things. The Telerik Platform, as I mentioned, it's a paid product. Everybody does get a free 30-day trial if you want to try it out, if you want to try NativeScript out using it. I think it's kind of nice. Anybody on Windows, we can help you out do iOS builds if you're a Windows user and you want to build iOS apps. But as I said, I won't be talking about the platform here today. If you have any other questions for me, feel free to grab me afterwards. I can give you a demo or anything you'd like to see. What I'll be talking about today is the NativeScript CLI, which, like the rest of NativeScript and the NativeScript runtime, is completely free, completely open source. You can head to the GitHub repo if you'd like to dig into how it works or you'd like to contribute yourself. Unlike the Telerik Platform, the NativeScript CLI does have some system requirements. It basically means you have to have the platform-specific SDK in order to build your apps. So to build Android apps, you're going to need to have an Android SDK installed. You're going to need to have a JDK. You're going to need to have Apache Ant in order to do builds. For iOS, you're going to need to have Xcode, the Xcode CLI tools, and an iOS SDK. Now from there, the NativeScript CLI actually works a lot like the Cordova and PhoneGap CLI that I mentioned earlier. We're actually big fans of Cordova and PhoneGap, and we didn't see any real reason to reinvent the wheel here. So the NativeScript CLI is based off of NPM, so you install it with NPM. It actually gives you 2 commands, NativeScript and TNS, because we're, again, lazy typers. So TNS Create to create projects. And I'm going to go through this kind of quickly because I'm going to show you this live in just a second. You have to run a platform add command to do some platform-specific configuration. Basically, like on iOS, this will set up your Xcode project for you. On Android, it's going to set up your Android project, add all the appropriate configurations and files that NativeScript needs in order to build your apps. You use the TNS run command to actually run your apps. TNS run Android or iOS. You can pass the -- emulator flag if you want to run in the iOS simulator or an Android emulator. So there's iOS, there's Android. Your project actually looks a little something like this. And at a high level, the first thing I'll acknowledge is that check out this app folder within an app folder. And like this was like, there was an internal conversation about this. We wanted to get this out before the public beta, and it didn't happen. So I can tell you that when 1.0 comes out, these files in here just move up a slot. Like we're no longer in this double. But just in case you look right now, yes, the first file you're going to see is called app/app/app.css. So, oops. But that is going away. But at a high level, the app directory contains the code that's specific to, I guess I should start with the platforms directory. When you run that platform add command and it generates all that platform-specific stuff, like your Xcode project and stuff, NativeScript's going to toss it in this platforms directory here. You would treat this as basically generated code. You'd exclude it from source control because it's something that you can always get back with the platform add command. And basically what NativeScript does is when you run your app, it takes these files from here and injects it into the platform-specific stuff in order to do the build, in order to build that actual Xcode project, to build your IPA for iOS, your .apk for Android. The other couple things I'll draw your attention to is this Tns Modules Directory. This is where all the NativeScript modules live. and you can actually dive in and just see their implementations right there. We have an app resources directory. This is for all the various like image assets, icons, splash screens, configuration files. Again, things that are just going to get injected into the platform-specific stuff. The core of your app, though, looks a little something like this, and I think it's fairly easy to understand. The first file to keep an eye on there is the app.js file, which is actually the first file that NativeScript's going to invoke. And it's going to look a little something like this. Fairly straightforward. Basically, all you're doing is requiring another NativeScript module and starting up your app. This basically just tells NativeScript what page you want to use. Say you have several pages in your system, which is quite common. You have to tell NativeScript which one to start it on. Now, the thing to note is, notice how main page has 3 files here: a .css file, a .javascript file, and a .xml file. NativeScript very much believes in the separation of concerns principle, or that you should have separate places to put different units of your app: the styling in the CSS file, the logic in the JavaScript file, and your UI declaration in your XML file. And I'll go through each of those sequentially, starting with XML. And I know what some of you are probably thinking, like, XML, why in the world would you use XML for anything? And I kind of hear you that I've been burned by using XML for data structures and data models before, and it's verbose and kind of a nasty experience. But XML, at least in my experience, can be fairly elegant for defining a UI. Like, basically, HTML is just another markup language, and people use it. I'm quite a fan of using HTML on the web. I don't think it's very verbose or ugly. And I'll show you some more complex examples. This is your hello world, so of course this is going to look simple. I'm going to show you some more complex examples in a minute. And I actually think the XML structure that NativeScript uses is actually fairly elegant and easy to read, even on some more complex examples. Another thing cool, though, I mentioned earlier about the NativeScript runtime and how everything kind of builds on top of it, and why I kind of delve into it earlier, is that each of these elements that you see here, these page and label elements here, these are actually also NativeScript modules. So you could dive into them and you can find the same implementations of them. And it means that you can also create and register your own components for use in XML. So if you find one of these tags that you want to use as part of your app that NativeScript doesn't yet have an implementation for, it means you can go in, create an implementation using the NativeScript runtime, and have a tag that you can use as part of your UI. The other thing cool about the NativeScript XML structure is that you can use data binding as part of it. Yeah?
So would you actually be able to style those XML tags using CSS?
Yep. Yep, and I'll get into CSS in just a minute. Yep. The other cool part of the XML aspect is that we actually have a data binding implementation built right in. And if you've done either like C# and XAML, or you've done any sort of front-end templating languages using Angular, Ember, any of these frameworks, this syntax may or may not look familiar, but I think it's fairly easy to understand. Oops, actually, I broke this example. I'll just go ahead and dive into the next one. Actually, sorry about that. I'll actually come back to this. What this is supposed to have is a double curly brace, but I'm going to dive into the live code in a second, and I'll come back to this data binding implementation. To get to your question about CSS is kind of the last component of NativeScript. And the CSS implementation of NativeScript, just to kind of set things clear, it's not necessarily the CSS you know from the web. Remember that this is a native app. This is a native UI components. There is no DOM. There is no HTML. And so it's not like you can just take a CSS file from your web app, drop it in, and say, like, oh, yeah, I'm going to have an application here. NativeScript actually has a list of properties that it supports, basically a whitelisted properties that are things that NativeScript is able to replicate in the native world. Things like color and background color are quite easy. The things that are harder are things related to layout. NativeScript actually has its own custom layout mechanism because, as it turns out, like re-implementing something like relative and absolute positioning and floats in native apps is prohibitively difficult, and it's actually much easier to use a custom layout implementation. So without further ado, I'm going to actually show you some apps. So let's turn on mirroring. All right, I'll clear this out. So as I mentioned, you can run NativeScript or TNS. So if you just run this thing, it'll just give you a giant list of the commands that are available. The same thing's available for TNS as well. You create projects with the Tns Create Commands. So let's call Hello World. Create that there. I'll head into it. If I list these things out, you can see there's the top-level app and platforms directory. If I start out, my platforms directory is actually going to be empty because I have to add these things. So Tns Platform, add iOS. iOS usually takes like 4 or 5 seconds if the demo gods are with me today. Android's usually a little bit quicker. What this is actually doing is this is kind of scaffolding up my project, the project-specific stuff, like my Xcode project and such. You can add Android as well. And hopefully that completes fairly quickly. There we go. Your project actually looks a little something like this. Remember apps and platforms? The platform add command actually did the scaffolding, so you can see things like your Android manifest file here. For iOS, you can dig in and find things like your Xcode project, all of that native specific stuff. In this app folder, I mentioned earlier, the Tns modules are just directly available, so you can see that they're all here. A lot of them live in this UI directory. I mentioned that the starting file was this app.js file. So if you wanted to see, for instance, how does NativeScript implement an application, you could kind of dive in here, find the Android-specific implementation, the iOS-specific implementation. NativeScript uses this kind of -common syntax for things that are actually shared across the platform, kind of setting up its API and such. Here's what the starting sample page in NativeScript looks like. This is actually the simplest of the NativeScript layout mechanisms. It's a stack layout. Stack layout is fairly easy to understand because it just says stack things up. You can either stack things horizontally or vertically. Vertical is the default. In this case, it's just adding a label, a button, and another label. So if I run this thing, run it on iOS. This usually takes a little bit of time to kick up, and in the meantime, what I'm going to do is bring up the JavaScript Logic, remembering the naming convention here on the right-hand side. Now, I mentioned the exports keyword before and how it's used to basically expose the API for a module. In this case, you can see that the mapping can be made here between this exports done in the logic, this page loaded function is being exposed, and it's actually being consumed in the XML here. What this is saying is when the page loads, subscribe to the loaded event and call the page loaded function in the XML. So basically this logic is going to run as soon as this page loads. This gets stuck. I'll have to check that again in a second. The other thing cool is this is the double curly brackets that I screwed up my slide on earlier, that this is NativeScript's data binding implementation. And so basically what this is doing is this code here that sets the binding context of this page. It's basically setting up an object that's used as the basis of data binding for this application. In this case, it's actually pointing at a different file that I'll pull up. This defines an observable, observable being another one of these NativeScript modules that you could dive in and find the implementation of. And if you look at the mapping here, you can see that this button is mapped to tap action, which actually corresponds to this tap action function that's exported from this model object here, and also the message property, which is set here and corresponds to the text on this label. And so we have this up, and the scale is way off. Let's get this thing tiny. Now what's cool about this is with the data binding approach, you can see that this JavaScript code, it doesn't tell the UI to like update itself, right? All it does is say, oh, when this happens, just change the message. And so because of that, when I tap this button, the message actually updates kind of magically or all by itself. And what's making that happen is the use of this observable object up here, and then just using the set call here to actually set the message. You can see that at the end, you get a nice message. We can take the 10 seconds just to get the hooray message here at the end, because why not? Yay, the NativeScript clicker achievement. But this is, again, fairly simple, right? This is kind of like a proof of concept for how the data binding works. But I still think it's fairly cool, because again, remember that this is a completely native UI. So this isn't just data binding between a div and a JavaScript object. You're actually data binding between true iOS controls and JavaScript objects, which is kind of mind-blowing and cool at the same time. But again, fairly simple. So let's bump it up a notch. I have a little list project here. I'll fire this up. Hopefully the folder structure here is starting to look a little bit more familiar. This time I'm set the main module of my app to this tasks page here. And I'm going to show this for a minute. And while this is running, let me just Let's try Android this time. Android emulator. We'll see if demo gods choose to be with me today. But before I show this, let's take a second to load up. I think as a testament to this XML syntax, I think, and I'll give you a minute here, you could probably give an idea of what this app looks like before you even see it on the screen. So this is using another one of NativeScript's XML layouts tags, the grid layout. What the grid layout does is it's basically a way of dividing your screen into a series of rows and columns. In this case, it's using one column, and it's saying this app should have 2 rows, the heights of which should be automatic and star, which kind of follow the CSS definitions. Basically, the auto means take as much height as you need, and star meaning take up whatever's left. You can nest these layout structures, so the stack layout appears within this. In this case, the default of a vertical orientation is overridden, saying display these things horizontally. So basically, in row 0, or the top of the screen, a text field and button appear next to each other, and at the bottom, taking up the rest of the screen, there's this list view available. And if I bring this up, oh, it's kicking in. All right. The first time it runs, it takes a few seconds. The other thing cool is this data binding implementation done on the items attribute. You can see how it's tied to this task element here. And if I open up the JavaScript implementation here, to follow this back, you can see that tasks is actually defined as this observable array. This is, again, just a light wrapper around a JavaScript array. But what this makes possible, I think, is pretty cool, because if I bring these up side by side, look at just how little code this takes. And let's see if we get this up. This will be up in a second. I can kick this up on iOS as well. Actually, we'll just give it a second to fire up. But basically, this button, using the data binding approach as well, the tap attribute is tied to this add function that's being exported. Again, exposes things from the JavaScript logic to the XML. So when tap happens, this add function runs. And to add things to the list, again, the tasks list shows on this list view. All that we need to do in our code is called the push method, and just let the UI take care of itself. So there we go.
There's like a white list of CSS properties that you can use, or CSS class, CSS functionality you can use. Is there also a white list for, like, basically, I don't want to say DOM elements, but XML elements that you can use? Like,
yeah. Yeah, so the question was, there's like a white list of CSS properties, what about XML elements? And yes, if you go through, actually I can open it up, but if you go to nativescript.org and you go to the documentation, you'll find a giant list of all the XML elements that are available. And you can dig through those and see what's available. You can create your own using that like kind of custom syntax I showed before. You can go to our docs and there's a way that it'll explain to you how you can build your own. Our idea is that we're trying to cover the most common things you need to do. And we're hoping the community can help us out too. It's all completely open source to build on top of some of these more niche things that people want. And to go back to my app, because of the data binding approach, when I push to the array right here, this list automatically builds up. Which I, again, think is pretty cool because this is all the code you need to build this sort of interface in a completely native app. So let's go. I've got 2 more here, and then I'll take some questions. So let's open up groceries. And I'll open that up. I'll run this one on iOS. So I'm trying to go increasing complexity here. Groceries, this structure is starting to look a little bit familiar, hopefully. In this case, I have several different views. I wanted to show an example. All of these so far have been just some kind of isolated thing. I wanted to show how a few things come together. This page actually has a login screen. So again, I think this is fairly readable. This is a stack layout, pretty stupid, just line things up on top of the screen. There's a username and a password field, and there's 2 buttons here on the bottom, one to sign into the service and one to sign up for it. The sign up is actually more or less, you can almost think of it like a HTML link, and it's implemented right here. So to connect the dots here again, on tap, this register function runs, which corresponds to the register function that's being exported from my JavaScript here. And in this case, all I do, this gets referenced to a NativeScript module here, and I call the navigate method and just pass it a reference to another view. And fire this up. That looks a little something like this. Again, remember, these are native controls, right? So you get the native iOS behavior automatically. See how NativeScript creates this navbar for you. And this is something you can configure if you don't like the exact way it does it. But by default, it creates the navbar for you with this backlink that you can use as part of your app. The same type workflow is in place for the actual login. Tap calls sign-in. In this case, this calls my backend to do this actual sign-in process. On success, there's a navigate call here. But if things fail, I'm actually using another NativeScript module, the dialogues module, to show the user an error message. So if I type in gibberish here and try to sign in, I'm going to get an iOS native alert that gives me an error message. And if I sign in correctly, if I can type things all right, I can actually see this is a little grocery list app. The way this works is actually just exactly like the previous app. This just builds a list in a list view as part of the screen. I can go back and forth. Again, these are native iOS controls, so you get the native iOS momentum scrolling as part of this UI table view built in just by using that list view element. Pretty cool. I actually like to show this example because I think this is a pretty good example of what NativeScript makes possible from a cross-platform nature. There's almost no code I have in here to do things differently for Android or iOS, and it kind of works on both platforms. Like that same sort of mechanism, that same sort of app will look fine on Android. In fact, the only things I'm doing differently, I do have a few differences. For iOS, I wanted to turn off autocorrect and auto capitalization, and I hate when I run across iOS apps that don't do this, where like you go to type in your username and it's trying to replace like your name with banana or something like that. So actually, we plan on implementing this into NativeScript Core for the next release, but it's not there yet. But what the NativeScript runtime makes possible is, again, when you need to make these native tweaks, when you're like, I really need to do something iOS specific, or I really need to do something Android specific, you can do that sort of thing. So I have an if iOS check. Basically, if an iOS field exists here, I'm actually going to change its auto capitalization type. And you could refer to the iOS docs. That's an actual iOS API that you can call. And NativeScript, because of that whole process with the runtime and the metadata, makes this sort of thing available to JavaScript, so I could turn off auto capitalization autocorrect. The only other part of this app right here, I have one other check. Actually, to show the title, I changed the page's iOS title. But again, pretty much this is the same basic app for Android and iOS. But that's not always going to be the case. When you're writing a native app, sometimes you really do want to configure not just like some little thing here or there, tweak something individually, but you want to create like a completely platform-specific view. You really, really want to take advantage of the platform you're running on. Like you have a really specific vision of what your iOS page should look like and your Android page should look like as well. And so I have one more example for that. We'll head into Maps, and I'll open that up. This app is actually divided into two pages. I have the views again here. It's your typical master details type app. The homepage is just a list. It's using things that we've seen before. It's just a list view on this page. It has its items set to a list of places. This app, I wrote it as like a place of the day type app. It just shows you a giant list of places. You click on the thing, you see details about that place. So all this is doing is throwing some labels on top as part of each individual item in the list to show some details about it. What's different and cool about this app is actually in the details files here. Now I showed this sort of .android and .ios star naming convention earlier, and I showed it in reference to NativeScript modules and how you could use it to fork your code there. But that same naming mechanism applies throughout NativeScript. So I can actually do it to fork, say, my CSS files if I wanted to use different CSS for Android and iOS. I could do it for my logic. I could do it for my XML as well. Now in this case, what I wanted to do, I wanted to show maps as part of this app, just because I thought it was kind of a cool thing to do. And so for the details view, what I actually did is I tied into the MK Map View APIs, which are just basically the same APIs that Apple provides for their Apple Maps, part of the iOS native Maps API. And let me get this thing started on iOS. And you can see that I was able to add this in let me kill this here. I think this is about 7 lines of code that it needs to happen. Again, this is iOS specific code. Eventually, this is something that I could take and abstract into like a map element so that I could actually type a map into my XML file. I haven't done that yet, but that's something that the NativeScript APIs completely make possible. And it's up here. So here's my master view again, another UI table view here. And if I click on each of these, what it's actually going to do is I'm getting the latitude and the longitude. It's kind of cut off here, but you can kind of see I'm getting that from my backend, and I'm using that to show a map. And this is actually, let's see if I can pull off this gesture. This is actually an iOS native app, so the performance is great even if I do stupid things like spin the app in a circle. I can go back, I could look at different places, get the maps to load there as well.
So TJ, how are you calculating the date?
How am I calculating, what's that?
The date.
Which date? The date shown here?
Yes.
Oh, well, it's coming from my backend. But I can show, actually, there's one thing I should show related to that. So one cool feature that I haven't mentioned as part of NativeScript so far is that remember that NativeScript is just JavaScript code. So one of the things that means is that you can just use Npm modules as part of your app as well. Now, that doesn't mean that every single node module is going to work. There's node modules that depend on the browser, right? There's ones that need the DOM. There's Npm modules that need like specific pieces of hardware and such. So I don't want to say like every Npm module is going to work. But the utility ones, like in this case, I'm using Moment. I've been playing with like underscore and Lodash. Those work quite well. Any of those utility type functionality, those things work pretty well in NativeScript. What I'm doing here is that, so this is the line of code that actually goes to my back end and gets data. And then because of the data binding approach, I can add to the array just using the push method to get it to show up on the screen. This is what it's actually configuring my date. I'm using Moment to format up that date from like the timestamp I get from my backend and actually showing it on the screen. So that's how that's happening. And then to go back here, actually, I could show you real quick what the Android implementation is. Unfortunately, pretty stupid right now. Basically, all I'm doing is using the Google Maps static images API. So I'm taking the same latitude and longitude, but I'm showing this for now. Eventually, what I plan to do is actually leverage the Android SDK, the Google Play Services SDK, to actually show a true Android map here. Hasn't happened yet, but because of the NativeScript native naming convention, I can just provide this as basically a fallback implementation. It's not as good, but I can come back to it later and put something in there.
So then for iOS, you're using the native map view. How do you load that data that's a result of Google for Android?
Right, so the question is, how would I load this sort of thing from Android? And one thing cool about this is, like, this data is actually coming, I'm passing it in this navigated to method. So when I navigate from the master to the details, there's some code in here that says, what data do you want to pass? And so I say, like, there's a call here that says, get all my places data from my back end. And then when I actually do the navigation from the master to the details, I pass the details page that data, or basically the representation of that specific place, so that the details can use it. And in iOS right now, I'm taking that latitude and longitude and I'm passing it to this iOS API. And then I could do the same sort of thing for Android as well. To me, the real power of this approach is that NativeScript gives you the ability to kind of fork where it makes sense in your app. So if you're building something that the cross-platform approach makes sense, because I think for especially some of the list examples I showed earlier, there's really no reason to actually go in and do platform-specific things, really. But when you really do need to fork your code, like when it's really important for you to utilize some native, very specific functionality, you can do that sort of thing. And NativeScript makes it possible. Yeah?
So the mkmap object there, is that at the global scope, are all of the native iOS APIs being injected in the global scope?
Yep, so the question was, are all of the native iOS APIs getting injected globally? And the answer is yes. So for Android, it's actually, I'm almost positive it's just Android and Java because of the way Java namespaces work, like everything kind of branches off of there. For iOS, it's absurdity, right? There's like, but everything pretty much starts with NS or UI, or there's a few exceptions like mkmapview, but most of them are kind of available and with those.
Like an iOS namespace, and then all the APIs, it's just, they're all right there.
Correct, they're all in the global scope. Yep. And that's what makes like these lines of code here possible as well. Yeah.
So, question, I've done some apps with Titanium, and one of the biggest pain points with that was memory management and memory leaks, especially with your heavy usage, when you're creating a lot of different views and a lot of different native components. How does NativeScript clean up after you use?
Yep. So the question was basically around memory management and how to handle that. And that's actually been one of our biggest challenges as well, because it's definitely hard to do when you have two completely separate Java or garbage collection processes going on. And so like the NativeScript runtime, like you could dig, I mean, if you really wanted to dive deep, like you could look at GitHub and like how we're doing it and how we're managing that. And we have code that does like the reference counting on iOS, and we have Android code for that as well. I don't know like the nitty-gritty details of exactly how we manage that. Like I said, if you have any specific questions for me, I can get back with you later. I can find the people that work on it. But I know that that's something like that's one of our biggest challenges that we do, managing that sort of thing. Yeah.
One question, like you just mentioned about the memory management. Do we have any battery usage as management, like how the battery is consumption of battery power and all that stuff?
Yep, so the question was about battery management and checking that sort of thing, and we haven't done anything with that yet. So that's something we could look into. But because these are really just calling native APIs, I wouldn't expect anything to be different than necessarily the same app just running natively. We've done like performance testing on this sort of thing, because another common question comes up is like, well, how fast is this compared to native apps? And we've discovered that like doing the actual bridge component of it, like there is a performance hit to doing that. Like that's not a free cost, but that it's fairly negligible for the vast majority of apps. Like if NativeScript probably isn't the greatest fit for your next 3D game idea, I mean, you could, and we'd love for you to try to do that, but I wouldn't necessarily recommend NativeScript for doing that. But for most things, like that small hit you take going across the bridge is fairly negligible. And actually, like the bridge portion of it tends to be a fairly small component of your app. I mean, I find for most common apps, you're spending most of your time in JavaScript. Like that's where your heavy manipulation is happening. Your objects, your data, your models are all in JavaScript. So the operations that you're doing on them are all within JavaScript. So they're all running on V8, and you're not actually making that bridge between JavaScript and native code. And these JavaScript VMs, the thing is, these companies have optimized the hell out of these things. Like JavaScript runs really fast on V8 and JavaScript core now. Like it can't compare with C++ code. It's like they're getting it within like a third or a quarter of the speed, depending on which engine and which benchmarks you look at. But it's still, for the vast majority of the apps, JavaScript runs really, really fast in these VMs now. Yeah, another question?
Would you say, is there any limitation to any sort of like UI components with the NativeScript? Like you can't do, let's say, like widgets on Android?
Yeah, so the question is, are there any limitations for UI components? And there shouldn't be. I think the tricky part is dealing with like our layout mechanisms and doing things to deal with it. And that's something we've been meaning to experiment with, and we're trying to get the community involved in helping to create these things, because we've been creating the common things. We're actually, one of the things we're really looking for feedback on is for people to actually create these things, especially the UI components angle, and to let us know what the process is like. As I said, NativeScript we've been public for a week now, so it's one of the things that we're trying to gather feedback on. But to my knowledge, there isn't anything specific that shouldn't work. Yeah, question back there.
So when a new operating system comes out, I mean, I guess the new version of the operating system comes out, it's not like they have access to the APIs to do that there.
Yep, so the question was about like new versions of the API, like Android releases a new version, iOS 9 comes out. And the answer is yes, like NativeScript basically can use the native APIs immediately. The only thing that has to happen is we need access to the new APIs so that we can run our metadata process, so that we can essentially regenerate to register the new APIs so that they're available in JavaScript. But as soon as we inject that new metadata, then the support is there. So we can provide basically immediate support, because we can do the metadata portion during like the betas of the APIs. Yeah, another question there. So the question is it backwards compatible to most devices? And you mean in terms of like older iOS versions, older Android versions? It's going to be subject to the same thing that native mobile apps are, so it's going to work the same way. Like we specify a minimum Android version. I think I think we're starting off to support Android 4.2 and greater as of right now, and that'll be our. It is a native app, so you can go in to do anything with the Android manifest that you would do in native Android apps. The metadata, it only goes back as far as Android 4.2. So right now that's our kind of hard limit. And the same for iOS, we go back as far as iOS 7 at the moment. The last thing I'll show in here, like I think what's kind of cool about this is that even when you do fork your code, like this is an iOS specific implementation, you still kind of get some benefits, right? Like I don't have to rewrite my code. I have model code to actually represent this place and such, but I don't have to rewrite any of that. Even when I'm providing these platform-specific views, I don't have to rewrite any of my code that actually like goes to my backend and talks to my database. So even when you are creating these, like even when you build basically completely specific UIs for each of these platforms, NativeScript still allows you to share a good chunk of your code. And let's go back here. And I have like 2 more slides up, and then I'll take any other questions people have. See if I can manage to click this button on the bottom of the screen. There we go. So that's my demo. As I said, NativeScript is completely open source. So if you find all the repos, the ones I list on the bottom here, we have our cross-platform modules. So that Tns Modules Directory, there's a GitHub repo that represents that. So if you wanted to build your own modules, if you wanted to try to get one added to core, submit a pull request. We'd love to have it. Or just create your own repo. Let us know about it. We're happy to share it. The command line is completely open source. So if you know Node and you want to contribute to our CLI, we'd love help with that as well. The bottom 2 are for people that really want to dive into C++ code. Those runtimes are where we're actually doing stuff like managing the JavaScript VMs, managing JavaScript, the VMs, managing garbage collection. That's where the real nitty-gritty of NativeScript happens. It's also where some of the more complex parts that I didn't get into this, kind of like how these objects actually get transferred. There's also like what's known as a marshalling service, what we call our marshalling service that actually does the data transfer itself. That's implemented in these runtimes as well. We'll have a Windows runtime coming out soon as well. It's still private, but we plan on open sourcing that soon so people can contribute to that as well. If you want to learn more about NativeScript, if you want to keep up with new things that we're offering, new things that are out, we have a Twitter handle @NativeScript. So feel free to follow that to keep up to date. We also have our blog at nativescript.org/blog. We have an RSS feed if you're into that sort of thing and you want to keep up as well. I'm TJ VanToll, and you could follow me on Twitter as well. Feel free to ping me with any NativeScript questions if you didn't get a chance to ask it today or you think of one tomorrow. I'll also be around today for the next few hours. Feel free to grab me and ask any other questions. And thanks. Yeah, question.
Is there any way to do element targeting? So, say I want to add an event listener after it's created. Instead of doing the on tap in the XML and then creating the export for that.
Yeah, so the question was basically, are there ways like in JavaScript that you can do things like register event handlers and do all sorts of things? And yes, so there are JavaScript APIs behind everything that happens in XML. They tend to be kind of verbose because you can say things like new stack layout module, stack layout, and then there's like append child methods. It's almost like a pseudo DOM implementation in a way that's kind of simpler. And you could do all those things in JavaScript if you really want to do those. But I show the XML syntax because that's the preferred way of doing it and the way we think is easier. Yeah.
I have a question. How customizable is the outer platform UI? And also, can you use CSS frame?
The outer frame.
So, for example, you showed that when the list moved to map, and we automatically got the back button from iOS. So that kind of a outer thing. Can you customize any of that? And then, as a sub node, can I use Bootstrap CSS?
Gotcha. Okay, so the first question was related to how customizable kind of like the defaults of NativeScript are and how it handles the outer UI. And the thing is, right now it's not very customizable, unfortunately. Like, if you dive into the native code, you could do anything. And so I've had a number, actually the number one question I've gotten like on Twitter and such is related to the iOS Navbar. Like it's apparently when people start an app, that's where everybody wants to start. I don't necessarily know why. But And so people want to show it on the first screen, and then they want to hide it on the second screen. And so you can write iOS specific code to do that. Like you can get the UI Navbar controller and has like show and hide.
Control it through the native API from JavaScript.
Correct. You can control it from the native API in JavaScript and do basically anything you want. What we're working on is basically we're trying to identify those things and making them more intuitive to be configurable as they come up. So for instance, our 1.0 release, because we've received so many darn questions about the Navbar, we're actually going to have a Navbar component that you can put in XML and use it to configure that way. And so basically that's our approach. Like when those things come up, we're going to try to provide better ways of handling it. But you can always go into the nitty-gritty platform-specific stuff when you want to. And then the second question was about CSS frameworks and can you drop in Bootstrap? And right now, so not really. One of our focuses is we're trying to make these things more themable, because one of our biggest problems is that you can dive, as always, you can dive into the native code and do whatever. So you can potentially make these beautiful apps, but we want to make them easier to make pretty, if that makes sense. Because right now, quite frankly, they're not. It's a bit too manual to do it. So we're working on it. Other questions? Yeah. In the back.
I wanted to show a live video. What's the best way to go about doing that?
Showing a video, you said? So the question is about showing a video. We don't have a video component yet. That would be a good one we could look into creating. I personally don't know the iOS or Android specific APIs to doing. I think the ideal, long term for me, is that somebody wrote a video XML tag that just took a source file that you could play. But that hasn't been implemented yet. We'd love for the community to do it, and otherwise it'll probably be on our list. The thing with any of the NativeScript modules is we basically have a list of the most common things that people need to do, and we've gotten through 50 or 60 of them. But as terms of mobile apps, there's thousands of these things. So what we hope with NativeScript is our model lends itself to extensibility. So we're really hoping the community can kind of help us with some of the more niche things as we're putting the more common things in the core of the framework. So question, yep. Yep, yeah, so the question is about the Telerik Platform, and if you want to see anything related to that and how it fits into, let me know.
Right. Where's that?
Yep, so Telerik and the NativeScript, the Telerik platform and NativeScript, basically NativeScript now is a first-class citizen in the platform, so you can use App Builder to build NativeScript apps. It is for developers as well, as part of App Builder. So come chat with me later, and we'll go through it. Yeah? The question about talking to databases through NativeScript? Yeah, so you would do that through the same way you would do it in a native app. So basically you need to expose a service over HTTP. And so what the example, my backends, they're all using that HTTP module to actually make the bridge, or to actually call those backend APIs. So you'd have to have some sort of REST API or the database. Oh, like SQL on the phone? Oh, yeah, yeah. No, that's a good question. I'd have to look into it. I'm not sure whether we've created a module for that or not. That'd be another example of we just have to create a module to tie into that sort of thing. Multi-threading? Not sure. Ah, gotcha. Yeah, I don't have a good answer for you right now. It's something we'd have to look into. It would probably be for that sort of approach. It's something that would have to be implemented in the runtime itself, I'm guessing. So I'm guessing chances are if that becomes a common request or problem, that's something that we could put into the runtime and make available. So, all right, if anybody has any other questions, I'll be around, so come grab me. Thanks.